So this was chemistry pop quiz 5, which was related to bonding, empirical formula, and the electrolysis tests. The first one is related to the structure of diamond and graphite. As you can see, the two structures, the left hand side is the structure of diamond, and on the right hand side is the structure of graphite. So which pair of statements about the diamond and graphite is correct? So we have to check which statement is totally correct. A pair of statements, like two statements together. The diamond and the graphite both are pure carbon. That is true, because like both contain carbon atoms and they are both macromolecules or giant structure. That's also true. So A will be the right answer. Why not B? Diamond and graphite can both be used as electrodes. That is wrong. Only graphite can be used as it has a electron is there within the structure which can help in conduction, but diamond cannot help in conduction. And graphite is used as a lubricant. This is true, but the first statement is incorrect. In the statement C, the diamond has covalent bond and graphite is ionic. This is correct, but graphite is also having covalent bond, not ionic. Diamond is hard with a high melting point and graphite is soft with a low melting point. It is soft, but not the low melting point. They both have a high melting point. Why they have high melting point? Because the melting point depends on the type of bonding. If there's a giant structure, they will have a strong intermolecular forces. As a result, it will have a high melting point. So both diamond and graphite have high melting point. Only the diamond is hard where graphite is soft. That is due to that one is having a tetrahedral structure, another one is having a layer structure. Sodium nitrite contains nitride ion. Sodium nitrite is unstable, decomposed to its element. What is the equation? First, what is the right formula for sodium nitrite? So sodium is group 1 plus 1 and nitrogen is minus 3. So sodium nitrite formula should be Na3 because when we write a chemical formula, we cross multiply. So which one Na3N? So this can be an answer, or so either B can be an answer or D can be an answer. Then when it break down, when a compound break down and it form its element. So if element is a metal, it will exist as an atom. But if element is a non-metal, it should exist as a molecule. So nitrogen should be N2. So sodium should exist as a sodium atom and nitrogen element should exist as a nitrogen molecule. So sodium atom and nitrogen molecule. Here, why D is wrong? Because here they mention nitrogen atoms, but it should be a nitrogen molecule because nitrogen is a non-metal. So whenever you have a non-metal, how should it exist? It should exist as a molecule. When there is a metal, how it should exist as an atom. That's why B is the right answer for this. Compound X contains carbon, hydrogen, and oxygen only, and its mass, it contains 26.7% carbon, 2.2% hydrogen. What is the empirical formula? So how to work out empirical formula? The compound is having carbon, hydrogen, and oxygen. So carbon is 26.7, hydrogen is 2.2. So how much is oxygen? We subtract, because the total sum of the percentage of all the elements which are present should be 100. So the total should be 100. So it is 26.7 plus 2.2. That is 28.9, and subtract this from 100. That will be 71.1. So oxygen is 71.1. Now after getting the oxygen, we divide by atomic mass. The first we divide by atomic mass. So atomic mass of carbon, that is 12, hydrogen is 1, and oxygen is 16. So 26.7 divided by 12, which will be equals to 2.225. This will be 2.2, and this will be 71.1 divided by 16. that is 4.44. Then we divide by the smallest value in the combination. So the smallest value in the combination is 2.2. So we divide this by 2.2, 2.2, 2.2. So this will be 1, approximately 1, 1, and this will be 2. So it means it contains 1 carbon, 1 hydrogen, and 2 oxygen by the ratio. So this matches with option D. In question 4, cesium fluoride is an ionic compound. Which statements are correct for cesium fluoride? It conducts electricity when solid. That is wrong. Ionic compound can only conduct electricity in molten or aqueous. It has a high melting point. That's true. Ionic compounds should have a high melting point. It is soluble in water. Most of these ionic compounds are soluble in water. And it has a high volatility. What is the meaning of volatility? Means like that it can easily be vaporized. But ionic compound cannot be easily vaporized. So which statements are correct? 2 and 3 are correct. Volatile means can easily be vaporized or converted into gaseous state. Yeah, easily evaporate, you can also say. That is a characteristic of covalent compounds. Simple covalent compounds are volatile as compared to ionic compounds. Brine is a concentrated aqueous sodium chloride. 3 substances which are manufactured by passing the electricity. Like we have aqueous concentrated sodium chloride. So what are the ions present? We have a sodium ion, we have chloride ion, we have hydrogen ion, and we have hydroxide ion. These are the ions present. Now, when we do electrolysis for a positive ion, we have anode and cathode. The positive ion, always the less reactive will move. So in this case, the hydrogen is less reactive. So hydrogen will move towards the cathode. So when hydrogen will move towards the cathode, so one of the product will be hydrogen. Then because it is a concentrated means it contains more Cl and less OH. So chloride ions are more, so chloride ions will move towards the anode. So when chloride ion will move towards the anode, the other product will be chlorine, the second product. So first product was hydrogen, move towards the cathode. The second product is chlorine, move towards the anode. And what is the third product? What is the third product means what is left? So when hydrogen is being removed and chlorine is removed, so what we are left with? We are left with sodium hydroxide or NaOH. So the third product will be sodium hydroxide. That will be the third product. So hydrogen ions move towards the cathode, so it will give off hydrogen gas. Chloride ion move towards the anode, form a chlorine gas. And sodium and hydroxide combine with each other to form a sodium hydroxide. Name a different substance formed when a molten sodium chloride is used instead of concentrated. So if we use a molten sodium, like this was for aqueous concentrated sodium chloride. But what if we have a molten substance? Like we have only sodium ions and chloride ions are there. So when we do electrolysis of the molten substance, how the products will be different or how the results will be different. So there's a sodium ion and there's only a chloride ion. So chloride ion will move towards anode and the sodium will move towards cathode. So what will be the different thing? Here hydrogen was forming, but in this case, what is the other product? That is sodium is the different thing which is formed. Is it clear how they're different when we are using an aqueous as well as the molten substances? Any doubt in this?
No, sir, no doubt.
Okay. So this was a pop quiz 5, which was related to some questions from bonding and empirical formula as well as electrolysis.